For over a century, cars have made our world go round. We've built billions of them. Thanks to evolving technology, they're made quicker and more intricately than ever before.
We have more than 1 trillion different possible combinations.
Any variation of colour, of material that you can think of, we can actually replicate in these rooms.
Nowhere are the stakes higher than in the world of luxury and bespoke cars.
We could potentially have a scrap car. It is that critical.
In this series, we'll see 5 iconic cars built from scratch. From bare metal to finished product. Using high-tech robots and clever techniques that are hundreds of years old.
We have a customer who has a piece of moon rock. We will be painting his Valkyrie in moon rock dust paint. It doesn't get more extreme than that.
This time, building the quickest and most powerful Aston Martin on sale, the DBS Superleggera.
The DBS is all about power. This is our brute in a suit.
From pencil sketch to 211 miles per hour supercar, it's one of the fastest and most expensive sports cars in the world. We'll witness the customization.
We get outlandish requests for colours all the time.
Craftsmanship and attention to detail that goes into creating this all-British super coupe from thousands of individual components.
The best part of my job is the pride in seeing everything come together and the cars driving off.
Following one car that must stick to schedule all the way through the factory. There's no room for error and no tolerance for imperfection, with a price tag of nearly £250,000.
You might look at it and you think, well, then the customer would never notice that, but at the same time, I've noticed it, so it has to be put right.
This is how to build an Aston Martin. Known for being hand-built, British and quick, Aston Martin is probably one of the most coveted car brands around, with a sporting pedigree dating back over a century. Founded in 1913 by racing driver Lionel Martin and engineer Robert Bamford, part of the name came from an old hill climb racetrack, Aston Hill in Buckinghamshire. But it wasn't until 1947, when David Brown bought the company, that it was transformed into a big name in motoring. The following year, Brown acquired a small luxury firm, giving his company its full name, Aston Martin Lagonda. Using his own initials, Brown started the DB cars and set out to prove Aston Martin's engineering credentials on the track.
300,000 people and more than 100 of Europe's best drivers were at Le Mans.
In 1959, Carroll Shelby drove the DBR1 to victory at Le Mans.
Salvadori's co-driver Shelby was flagged home the winner. They'd driven 2,700 miles. With them on the lap of honour rode Sterling Moss and David Brown. Good for Aston Martins.
In 1964, a relationship began that became a marketing dream when the DB5 was made the car of choice for 007 in Goldfinger. Since then, a DB car has appeared in 10 further Bond films, securing Aston Martin's fame.
I guarantee you will never get as many thumbs up from other drivers as you do when you drive an Aston.
In Gaydon, in Warwickshire, is Aston Martin's HQ, a purpose-built site dedicated to producing over 6,000 cars a year.
We have about 3,000 people. Our principal design studio is located here. Engineering is almost entirely located here. Likewise, manufacturing engineering and manufacturing itself. And it's quite unique in that sense because everything is here together. Most importantly, we manufacture all the sports cars here.
The size of 4 football pitches, this busy factory produces about 120 cars every week. Prospective customers can choose from the Vantage, the DB11, or the latest car to come out of Gaydon, the jewel in Aston's crown, the DBS Superleggera.
It's the best of what we are. It's beautiful, yet brutal.
The DBS is the company's fastest and most powerful car on sale.
The sound of the car is like no other, that howling V12 engine.
It can produce 725 horsepower, about the same as 5 average family cars. And its massive power, coupled with lightweight panels, mean it can top 200 miles per hour.
As a means of taking you from A to B, and A to B could be one end of the continent to another end of the continent, there is no more beautiful way of making that journey.
But all that comes at a cost of £225,000, unless, of course, you add optional extras. The DBS we'll follow needs to be complete in 49 hours to hit its production deadline. It's being built for a customer in the USA who specified xenon grey paint, a black leather interior, 21-inch twin-spoke wheels, and a carbon fibre roof. All ready to begin life in the USA at a cost of just under £237,000.
This is the Gaydon Aston Martin body shop production facility. In here we've produced all the new models, including the DBS.
The very first step for our car takes place in the body shop. It's the building of the chassis, or tub. It will take 5 hours to complete, and it'll be the starting point on which all other components are fitted. This aluminium platform is the part of the car that doesn't crumple in a crash.
It is the structure of the vehicle. It performs in a crash condition. It's the same as a welded structure for a traditional car. It's about assembly of 200 panels. We use adhesive to hold them together, which is cured through an oven.
You heard him right. This car's chassis is held together with glue.
While the glue is still wet, we use assembly fixings or fasteners just to hold the car together mechanically until that glue is cured.
To set this glue hard, it needs to be baked at 200 degrees centigrade. When our chassis comes out of the oven, its strength is tested, and then 4 robots check the location of around 1,000 points on the car. Our car can't continue to be built up unless all of its dimensions are precisely correct. Happily, it's a pass from the robots, and it's on to stage 2. Our DBS will now spend 6 hours on the body in white line, where the skin of our car will be fitted.
When the car starts its journey down the body in white line, we start a process called foaming and sealing, where we seal the car up to make sure there's no water leaks. From then on, we start to bond on composites of the vehicle. First station being what we call cold cure, where we put the wheel arches and we put the boot aperture of the vehicle in.
Some of the panels in all DBSs are made from carbon fibre, a material that's both strong and light, earning the DBS the Superleggera or Superlight part of its name. Aston claims this shaves 30 kilos from the car's overall weight.
What you'll see here is the adhesive, the structural adhesive being applied to all components in the car.
Known internally as the James Bonder, this is the robot that applies the bonding adhesive to the panels. It's not a common practice in car manufacturing, not yet anyway.
It is definitely a modern thing to glue cars together, yes, to use bonding technology. Some of the car manufacturers that we've got out there do it, but we're one of the ones that have been doing it for the longest period of time.
The final job in body in white is done by the biggest and most impressive machine of all, the framer.
So this station here joins the body in white and the crash structure of the vehicle together.
The framer's job is to fit our car's side panels onto its chassis. It'll take just half an hour, and it's completely automated. With our car and its side panels loaded, the framer gets to work. 2 robotic arms working simultaneously add glue around the edges of the panels. Then the panels are pushed onto the chassis. For this process, our car doesn't need to be baked in the oven. Instead, the framer's heat lamps provide the 200 degrees needed to set the glue.
The bright parts that you can see there are IR lamps, which are curing the adhesive. They're force curing the adhesive to just speed up the station time.
And after 20 minutes of heating, the two sides are permanently attached. Finally, the car has its bonnet, doors and boot lid attached. Our DBS has spent almost 10 hours becoming a body in white. Before moving on to paint, it must go through the metal finishing line, where the bright lights in the highlight station show up any imperfections. Tiny blemishes in the metal are filed and polished, and we're left with a perfect body.
The Aston Martin brand relies on the quality on the exterior surface of the vehicle. Our paint standards are very, very high. Therefore, if we put anything into the paint shop which has got a defect on it, it will show up after the paint shop. Therefore, we'd rather fix it, find it now.
Our car is lifted onto a trolley along with its bumpers and mirror caps, ready for stage 3, paint. A 181 people work here in the paint shop. It's the most labor-intensive area of the entire plant, where most of the work is done by hand. To achieve its flawless finish, our car will spend 35 minutes at each of the 32 stations.
Here at Aston Martin, we'll prime the car, following primer, we base coat the car, and then we clear coat the car before we go to the final process, which is the polishing.
The carbon fibre panels first receive a conductive pre-primer coat. The primer is then applied with an electrostatic charge, sticking it evenly to all the panels. The interior primer is done by hand, while the exterior is sprayed by robots.
The guys will be checking the cars over for any imperfections, because it's much easier to see defects in the panel once you've applied some paint.
After 6 hours in paint, it's time to apply the colour coat, which, depending on the finish, will either be applied by hand or robot. Our Xenon grey paint is one that's applied by robot. After parting with £225,000, the colour of a DBS is a big decision for any customer.
So now we're in one of the spec rooms. Here we can go through all the different elements, the different colours that are available, but then there are more unique colours. In all of these drawers are colours that there may have only ever been one made. So you can gradate your car from front to back, gloss to satin, or black to white, or blue to lighter blue. So we're able to hand paint and hand finish cars here as well. And that again means that most paint schemes are unique to the person that's choosing them. We get outlandish requests for colours all the time, and for me it's to work with the customer, work with the client to make sure that A, it's what they actually want, and B, it's going to suit the car. But we have an incredible customer, US customer, who's a Valkyrie customer, who has a piece of moon rock. He has ground the moon rock into a paint, and he will be painting his Valkyrie, or we will be painting his Valkyrie in moon rock dust paint. It doesn't get more extreme than that.
After colour, lacquer and polishing, our now grey car has been in the paint shop for nearly a full day. It's scrutinised in a light tunnel and finally signed off. Our DBS body is ready to become a car. Now 154 technicians need to add thousands of parts. With a series of tight deadlines, everyone will have to keep up the pace.
Critical that it's finely tuned to make sure that each technician should finish harmoniously all at the same time.
And every component will have to be ready to fit at just the right moment.
We really have to stuff up to get the wrong one in the wrong sequence, basically.
Plus, our car needs an interior, a 725 horsepower engine, and a lot of testing. And it must be complete in just 17.5 hours. We're inside the secret world of Aston Martin, witnessing one DBS Superleggera go from kit of parts to finished supercar. We've seen the coming together of metal components to make the chassis and body. The Aston team now has just 17.5 hours to install an engine, running gear and interior to complete our £237,000 DBS on time.
The DBS is all about power. This is our brute in a suit, if you like.
It took the team around 4 years to develop the brute in a suit, from just an idea to a finished car. Kicking off the creation of each brand new car is the job of the 80 members of staff in the design studio.
Everything begins here. So from the first drawing to clay modeling, CAD modeling, everything begins in this studio.
The designers measure beauty using the same key proportions that artists and mathematicians have applied for thousands of years.
Basically, when we talk about a GT car, it's all about proportions. Yeah. So, and we talk about the golden section. So it's the 1/3 to 2/3 ratio. So Aston Martin is about proportion.
You look at our cabin as well. So you've got the 1/3 here and the 2/3 here, almost that proportion swapped around again. And also with our body side and how our sections work, you got the 1/3 here and the 2/3 here. So it's everywhere we try and apply that logic.
It's effectively a dynamic sculpture. One of the most important aspects of our cars is the movement that you see in the bodywork. And what do I mean by movement? If you look at all the light lines, the highlights on the car, they're very dynamic. As the camera or your eye or the light passes over the car, it has a very fluid movement to it. It's got a direction and movement.
For the designers to be able to visualize and refine the lines of the car, a clay model is made, giving the design a 3D physical form. The modelers use foil to give the clay a surface that simulates painted metal, helping the designers see what the finished car will look like.
We have special lights in our studio, which we can directly see a reflection on our surfaces. So if there's a dip in the surface, we can easily see a mistake by having these highlights. And this is like a control key for us, for the surface, to see if a surface is correct or not.
5 different scale models of the brute in a suit were made, with one design going on to be made into a full-size model. It cost £200,000 to produce and was worked on 24 hours a day until it was complete. After clay, computer designs are made for further tweaking, and the designers work closely with the engineers to make sure what they've drawn can actually be made in reality.
We work really closely with the design studio. Obviously, it's really important, the number one attribute that sells an Aston Martin is the way it looks. I'd say the number 2 attribute is the way it sounds and the way it drives. So what we do is my engineering team is we have an aerodynamics team that sit very closely with the design team to make sure that what they're designing also has a function as well. Because there's no point having a car that looks beautiful but doesn't have the level of aerodynamic performance we need to achieve our attributes. Huge wheel and tyre on the floor here. We have to have tyres of this size. The diameter is very important to design because they like the cars to look like they're very muscular. In terms of the section and the width of the tyre, it has to be 305 section because we have so much torque coming from the engine. We need to be able to put that torque and translate it through to the tarmac or through to the road surface.
On the factory floor, our DBS body, now finished in grey paint, is on an autonomous laser-guided vehicle. It's been in build now for 22 hours, and it's time to hit the assembly line.
So this is the start of the DB11 and DBS assembly line. It's where we turn the shell of a car into a full and final finished car driving off the end of line. So the first step for the car is it to be stripped down into its ready position. So all the body panels are removed, the doors are removed, the bumpers, the aprons, and the clamshell go to their relevant sub-assembly areas. The bulk of the panels are located to the platens, and once fully assembled and secure, they get sent up and then are delivered to the next bit of the plant for the next stage of their build process.
The bonnet roof and bumpers are stored above the line until they will be reattached later, whilst the doors head off to their own mini production area.
You can see that the car's now being transferred over to join the main line, which operates in a horseshoe shape, so the cars come off the other end. 34 stations later. In total, we have 84 technicians working on the assembly line. So although the cars are still made by hand, we do use state-of-the-art technology via tooling, process control, and the interlocks to the track, ensuring that all of the critical processes are complete. Each technician has their process deck available to them, as well as the build standards on touchscreen TVs on each of their stations that they can log into, validate that they're building the cars correctly. We also control serial number scanning and parts confirmation to make sure we've selected the correct component or not.
There can be no slacking off. These guys are always on a strict deadline.
Each station has 24 minutes worth of work as it stands to current tact. It's critical that it's finely tuned to make sure that each technician should finish harmoniously all at the same time. There are problems that may arise, but we have a supervisory team to overcome that. So at the end of the 24 minutes, when everybody's ready to go, the line will then move on, and then on, and then on until the car reaches its completion.
The very first 24-minute job on the line is to fit a series of important but unseen parts that our owner will probably never know or think about.
You can see there's a lot of stuff here which is often hidden from the customer. You have the NVH sound deadening blankets to improve the customer ride experience, keep the noise down to a very minimum. We also have several miles of harness of electrical wiring that give the car its functionality. It's very important to the brand. We have to get the customer experience exactly spot on, so we still want them to have that raw feel of a sports car. However, we want them to have the luxurious feel of a GT and the comfort of the drive, and the NVH deadening is critical to that.
The NVH reduces the amount of noise, vibration and harshness that enters the cabin. In the nearby trim shop, our car's instrument panel, or IP, is being built. The IP has its own production line of 7 stations. 10 people work here building the complex dashboards on rotating jigs.
Spin them around so that they're always the most ergonomic orientation for them to do their job. We add on the heating, we call it the HVAC unit, heating, ventilation and cooling. That gives all your heating and your air conditioning in your car. You've got to go and be able to cope in the cold in Russia or the hot weather in California.
The IP is loaded with electronic tech, from the clocks and dials to the multimedia units that must be programmed according to the country each car is going to.
So here we flash all our multimedia units, so depending on what territory the country goes to, we'll put it on a different flashing unit, and then we'll set that up so that when the car goes to that country, it's all got the correct frequencies for stereo, for DAB, for your sat-nav, for your GPS.
The IP is finished in 20 leather-clad panels, offered in 34 standard colours, although bespoke colours can also be requested.
So we get the leather pieces and everything, so we've got the top pad, which we do the subtle assembly to. And then we get those different parts, our steering column, shroud, the binnacle cover that goes over the top of your instruments, to your ski slopes and your side panels. So we call the ski slope, they're the sides that go down of your infotainment. So in the main bit of your Aston Martin, the centre of it, you've got your control panel and your sat-nav screen, and we call the bits of leather down the side of the ski slope.
After 3 hours' work, the top pad of the IP is fitted and it's given an electronic test. Back on the main assembly line, our car's IP is ready to be installed. It's been finished in black leather with a carbon finish.
The IP is very heavy and cumbersome. This is why we use the assister to make sure that the techs have got full control as they're located to the vehicle. It's very important not to trap harnesses or damage the leather. We need to make sure everything's correctly aligned through into the engine bay, as well as making sure it sits square and firmly into the vehicle so that the bolts can be torqued up securely.
The next big piece to go on is the roof. Our car's roof will be finished in carbon fibre. It's an option that's cost our customer an extra £3,000.
So here, not only are the front and rear screen bonded, but also the roofs are bonded onto the coupe cars. So here we've got the PU, the structural bond adhesive, being applied to the roof. It's the same adhesive we use for the front screen and rear screen. Using the robot gives us repeatability and right first time application to ensure we have no wind noise, water leaks, wind disruptance into the cockpit. The roof can vary from car to car depending on what spec the customer selects. They have a wide number of options available to them. Some will want the carbon fibre finish, some may want the body colour, some may just want a plain black roof. So really dependent on the customer requirements, we select that here on Trim and Final as opposed to having a one-size-fits-all throughout the whole of the build. Yeah, we have a wide spread of colours. There's an extensive palette available, I believe, but we get some pinks, some greens, blues, some very abnormal colours that you would say, and some strange colour combinations that are very unique to specific customers. It's the horrible ones that make you look twice.
The same team then fit our car's windscreen glass.
The car's starting to take shape now. It's coming to the first stage of its build. We now send it ready for all of the underbody work through the slings and powertrain assembly.
The car is then raised to allow all the 84 technicians on this part of the assembly line full access to its underside, where brake lines and fuel lines are fitted, all in preparation for the powertrain. The powertrain is essentially the car's vital organs, all the moving parts that make it drive and stop.
There's about 12 people working in here. It's a linear build in the main. However, we have the two areas building the subframes, and they all converge in the middle, ready for transferring to the marriage station online.
The front subframe of our car was removed from the chassis at the beginning of the assembly line. It's now delivered to the powertrain assembly, ready for the engine to be fitted. The technicians here have 3 hours to assemble the powertrain before it's due to meet the car body back at the main assembly line. The 12-cylinder 725 horsepower engine has been delivered to Gaydon, having been assembled at Aston Martin's engine plant in Cologne. The first step is to fit the flywheel, an important part that helps to smooth the output of the engine.
So in the next build stage, the aircon pipes are fitted to the underside of the torque tube. The torque tube contains a prop shaft to take the power from the engine to the transmission.
Whilst the front subframe is assembled with engine, front suspension and brakes, the rear subframe is built up with the car's 8-speed gearbox, as well as the rear suspension and brakes.
So the front structure, its assembly is complete. From here, it awaits the main assembly coming over from the spine of the assembly area. This will all be mounted together, and that now becomes a complete unit.
Both subframes are now joined by the prop shaft, which sends power from the engine at the front to the driving wheels at the back. And finally, the exhaust is fitted.
And it's ready to make its way around the track, and it meets the marriage station on the main line.
Next, our powertrain needs joining to the right body.
We really have to stuff up to get the wrong one in the wrong sequence, basically.
To finally become a car. And the team need to power through to hand make the interior, all in just 11.5 hours. We're following the build of a £237,000 supercar, an Aston Martin DBS. Our car is almost halfway along the 34-station assembly line, and it's still in 2 halves. We have a floor carrying the engine and running gear, and a chassis, the body of the car, which so far contains just wiring looms and a dashboard. The next stage is vital to get right. The joining of our 2 halves, known as the marriage.
Here we are on station 3190, the marriage station we call it. This is where the fully assembled and tested powertrain unit comes from the powertrain assembly area and now meets the car. On this dedicated station, we have the ability to raise and lower the floor, i.e. the powertrain itself, and bring the chassis, the assembled tub, down to meet it, so So it really now starts taking the form of the car.
Each powertrain has its own unique label to ensure it meets the right body. The bolts connecting the two halves need to be lined up perfectly and tightened to just the right torque settings without trapping any wires in the process.
The marriage has now been completed. The technicians raise the car up, where it allows us to move the marriage bed ready for its next unit to be assembled on. The technicians will do a validation exercise and ensure that the right powertrains fit into the right car. In reality, the sequence should dictate that once the car's built in powertrain, it should naturally fall in sequence in line with the assembly track itself. We really have to stuff up to get the wrong one in the wrong sequence, basically.
Next, the bonnet is bolted on, followed by our car's 21-inch wheels and extra-wide 305mm tyres. These rear tyres are around 100mm wider than the average car, giving the DBS greater traction and forcing it to stick to the road at high speed.
The car now is about halfway through its build. It's started taking the shape of the car, but there's still many of the outer panels still to fit. There's still the interior trim to fit. It's still got half of its journey left to complete on the assembly line before it then moves on to the next testing and dynamic validation.
One important thing still missing is the interior, which for a prospective DBS owner can be rather complicated.
Most cars are different. The customer has quite a great option to choose from, whether it's the leather colour, the colour of stitch, the material that's used, whether it's quilted, non-quilted, perforated. So not many trim kits are the same.
To be successful in today's high-end supercar market, Aston knows offering customization is critical. Every customer wants to know that their car is unique. Incredibly, there are over 3 million possible combinations of interior materials available, and making each customer's wish a reality is the job of the trim shop.
The trim in the Aston Martin is part of the heart of the car. You know, it's the luxurious cabin where people sit and they want in one of the GT Grand Tourer cars. They want to feel that they're in a very sumptuous environment.
The trim shop will complete 19 DBS interiors today. Our car's black interior has already taken 50 hours to complete. Much of the work is done by the shop's 30 sewing machinists who hand-stitch the leather.
So we have two sections for sewing in the trim shop. We have this section here, which is the rear environment sewing, and this is all the rear cabin of the car. So your rear seat backs, your rear quarters, your parcel trays, your headlining.
200 individual pieces of leather need to be sewn to make a DBS interior.
So these are sewing leather panels which are backed with foam. They line, you can see the several notches around here. They'll line the notches of the panels together, and then they'll do a sew on the reverse, and then they'll flip over if it's got a top sew, and that's the stitch that you see on the outside.
The stitching from each skilled worker is unique. Nobody sews exactly the same. So to ensure consistency, the same person needs to sew all of the visible top stitches for each seat in a car. They then sign the back of every piece.
So it's about 4.5 hours to sew a full set of seats for a DBS. So that's the driver and passenger seat.
Technicians are then given 40 minutes to build and cover each seat with the freshly sewn pieces and to make sure there are no creases.
So once the seats have been finished being assembled, we come over to our final station, which is our electrical buy-off. So each seat goes through an electrical test, and then it will go through our quality inspection. So we'll pick up any defects within the seat where there's any slight wrinkles, and then we'll finesse those to make sure it looks perfect before going over to the production line.
The rest of the leather parts for the cabin are built up by expert trimmers.
In essence, what they're doing is applying the leather to the panel with the glue, but they're making sure that the leather follows the form, that when you've got a stitch line that goes around the part, that the stitch line runs straight and runs true and follows the form within the car. What they'll then do is make sure that they cut all the openings for any ancillaries that need to go. For example, on these panels that we need to add speakers in and bezels for seat belts, to make sure that they're cut nice and neatly around those openings.
To gain the skill to do leather work at Aston Martin takes 4 years of training.
With leather being such a natural product, you can get variation from hide to hide, how they stretch differently, and the guys here, they know how to deal with that to get everything to look as good as it does.
Our car's interior has been made from 200 pieces of black leather. The customer has chosen to have triaxial quilting and carbon fibre inlays. It's cost an extra £5,000. Our car's completed trim kit has been made from 27 parts which are delivered to the car on the assembly line.
The next trim kit's been delivered to line. It has all of the interior components, both from the upper environment, i.e. the cant rails, to the rear quarters, the rear seats, and the centre console. The rear console has gone in, the rear seat backs are about to be bolted in, and then the rear quarters will follow. There's a requirement for knack and finesse to make sure that the trim is fitted without gaps, without clashing, and is fitted to the exact inspection standards that are required.
On this station, on the inside, I'll fit the headliner, this rear header here, the front header, sun visors, and that's it for the inside. And then on the outside, I fit this leaf screen all the way across, DC to all these bolts, the windshield wipers, and then that's it. That's everything I do. The hardest part would be the leaf screen. Can be a bit of a pain to get in.
Our DBS may be nearly complete, but there are only 4 hours until it must leave the factory. And it can't hit the road until it passes rigorous quality control.
I mean, I can sit and go around the car and probably find a load of stuff which the customer would not even notice. It has to be put right.
And a series of checks and tests designed to ensure every component is 100% correct.
So the customer gets in his car, drives his car away from the cost that is paid for it, and everything's absolutely fine with the car.
We followed an Aston Martin DBS built up from bare metal. It's now just 4 hours from completion, after which it needs to be ready to ship out to its new life in the USA. The final few stations on the assembly line begin with the seat fit.
So once the seat's located, the electrical connections are made to make sure that we've linked the seat to the car. Then afterwards, there's 4 bolts which fasten the seat to the car.
Next, the steering wheel and airbag are installed. The doors that were removed 14 hours ago are now reunited with our car.
So they've been through an electrical test cycle. They each have a ticket with a clean bill of health, and that's the point at which we can transfer them to line. They're in the same sequence as they came off the car, so they'll go back in the same sequence onto the car.
The doors are installed with their electric functions, window glass and upholstery. And the bonnet is painstakingly aligned with a tolerance of between 0.5 and 1 millimetre.
Profiling of the car is quite a complex. Each panel relies on the position of its previous panel. So in order to fine-tune and set that, for every panel you move, you have to move everything that's adjacent to it.
If the gaps between panels aren't uniform, the car won't look perfect. The experienced technicians use a gauge tool to measure gaps, although they don't really need them.
The technicians on this station would pretty much be able to tell you by eye how big a gap is or how big a step is before they get their gauges out. So they'll tend to go around, tweak to where they can visually and historically know with their experience they've achieved the standard, and then they'll go around with the gauges to validate that they have actually achieved that standard and there's no variance in taper.
After 30 litres of petrol is put in the fuel tank, there's only one stage left on the line, and it's one that could make or break our car: quality control.
So the auditors are looking for any defects or anything within the car that doesn't meet the inspection standard. There's an element of functionality checks as well. They'll look to validate the spec of the car to make sure each component is exactly as the customer's ordered, as well as it meeting appearance standards.
Extra strip lights in the quality control stations make every area of the cars visible to the auditors. So scratches and other cosmetic defects can't hide in shadows. No matter how tiny an imperfection, these guys will pick it up.
Some things you might look at it and you think, well, then the customer would never notice that. But at the same time, I've noticed it, so it has to be put right.
If there's a critical fault, an error with a safety feature, our car will need to be taken away from the line and rectified. But with small issues like a crease in a seat, it's fixed there and then. These auditors will be the first to hear our engine start, although at this stage, it won't yet have its evocative V12 roar.
They don't sound great when they first start up, just because the systems are all being primed. So if you think the fuel at the moment, it's all sitting in the tank. It's like you can hear the engine turning over now. It's just waiting for the fuel supply, the fuel pumps to provide it.
It's the moment of truth. Has our car passed, or has there been a crucial mistake?
It's a good car, good to go.
It's a pass. Our car still hasn't reached the end of its build journey, but with all the thousands of components in, the engine working and panels aligned, the assembly line team have done their bit.
The best part of my job is the pride in seeing everything come together and the cars driving off as good as they are at the end of life.
Our finished car is about to be subjected to 2 hours of testing. For nearly £250,000, the customer needs to know that any hidden niggles, noises and faults have been uncovered and fixed. First up, aligning the wheels with the steering.
That centralises the wheels, centralises the steering wheel, so obviously a customer can drive his car straight and not on an angle.
The headlights are set according to the road rules of the country the car will go to before it begins dynamic testing. A series of checks with the car driving under its own power. This rolling road allows the car to drive without actually going anywhere. A powerful wind machine subjects it to the sort of resistance it'll be up against when driving at speed.
So you'll see the car actually start bouncing on its wheels. That's the time to make sure we've got no rattles, we've got no squeaks in it. Then what you'll see a robot arm, and that's controlled with wind. Now, the wind actually comes out at 100 miles an hour. So what we're looking for, it'll come around the mirrors, it'll come around where we think wind noise could happen when the car's going forward.
Aerodynamics was a major factor for the car's designers and engineers, helping it to minimize air resistance when moving and to make sure it has enough downforce to keep the wheels stuck firmly to the road.
There's a lot of aerodynamic details on the car. You have a front splitter. You obviously have to have big apertures on the front of the car because you have a V12 twin-turbo engine, 5.2 litre. You obviously have to cool that horsepower. So you have to have big openings. So we have to have a balance between cooling performance and aerodynamic performance. So on the front of the car, we have the splitter. You'll also notice within the wheel arch area here, we have vents that basically take the high pressure from the front arches, bleed the air down the side of the car. And then you will notice here that you've actually got the wing mirror is aerodynamically designed to effectively take this air and spill it into the C-pillar or the aero blade duct and also down the side of the car as well. On the sills, you'll notice there's quite an extension on the sills. This also adds to the level of downforce that the car achieves. So what I'm trying to say here is there's lots of details around the car, and the sum of all those details together is what generates the downforce.
Our car undergoes another 90 minutes of tests, mainly designed after customer feedback to make sure the driver only hears the roar of the engine and no unpleasant sounds.
We've added that facility in there because we was getting cars that were rattling and squeaking. So we've put that in there and we are picking things up that you wouldn't see with the eye because it's bouncing or it's rattling about, but at least we know something's happening with that car prior to going out to a customer. So we know now we're going to give a customer the right car that he wants.
After a check of the car's 360-degree cameras, it can finally hit the road. well, the simulated road.
This is what we call the squeaks and rattles. And the reason why we call it, if you just actually look the sort of road, the terrain the car's going over, we're trying to replicate everything that you'd see or the car would do even more fiercely outside. And we're quite comfortable once that car's done, that car's a good quality car, free of any rattles or squeaks.
Some heavy accelerating and braking, plus a quick figure of 8, confirm that our car contains no loose components or annoying sounds. With a last electrical check that even tests the decibel level of the stereo, our car can finally be adorned with its wings. Aston Martin's wings are made by jewelers in nearby Birmingham, and even the badge can be customised. Valeted and free from fingerprints, the car is covered for protection during transportation.
That's the car done. It's a real pleasure to be part of Aston Martin. It's got to be one of the best cars on the road.
As more DBSs begin their long build back in the body shop, our car leaves a fully working 200+ miles per hour supercar. It's taken 49 hours and thousands of components, and it can now start a new life on the other side of the world.